Okay, now we're going to move into section 4, chapter 7. We're going to actually start taking a look at naming ionic compounds and taking our way through. Again, as you recall, to just get a brief recap, we've started with an introduction to chemical bonding, followed by a look at representing chemical compounds. Then we did ionic charges. Now we're going to see how we put this all together and write ionic compounds, write formulas and name them. And then we'll shift over and do molecular compounds and acids. So the objectives for this area are being able to apply the rules for naming and writing formulas for binary and ternary ionic compounds. That includes the course with ternaries, the polyatomic ions. So very simply, let's just start off. A binary compound, 2 elements. They're ionic. Therefore, that means they have a cation and an anion. To write the names, just write the ions. We've learned how to write the ions back in the last section on ionic charges. Let's see how this works. With your group A, of course, it's a piece of cake. Write the metal, then write the nonmetal. For example, NaCl, sodium ion, chloride ion, it's called sodium chloride. Magnesium in the bromide ion, magnesium bromide. Piece of cake. The problem, of course, is the transition metals. You've got to make sure you know their charges. Remember, ionic compound has to be neutral. So the cation charge and the anion charge must equal each other. Same number of positive and negative charges. So you look at the anion first to determine what the charge is on the positive ion. So let's try this formula. We need to know what charge copper is. We know that copper is transitional, so let's see what's up. Oxygen is, of course, oxide is 2 minus. Therefore, in this case, there's 1 copper, so it must be 2 plus. So we write copper 2 oxide, Roman numeral 2. Okay? Try this one. Chloride is 1 negative. There's 3 of them, therefore there's a minus 3 charge. Therefore, cobalt itself has to be 3 plus, so we name it cobalt 3 chloride. Okay, let's try this one, Cu2S. Sulfide is 2 minus. There's 2 coppers. The 2 of them have to be 2 plus, so since that means each one is 1 plus. Take a look at that again. Make sure you understand. There's 2 coppers. There's 1 sulfide. The sulfide, of course, is 2 minus. Therefore, the 2 coppers have to add up to 2 plus. Since they have to add up to 2 plus, that means, and there's 2 of them, that means each one is 1 plus. So it is called copper 1 sulfide. Okay, let's try this one. As you can see, white oxide, negative 2. There's 3 of them, total negative 6. Therefore, the 2 iron have to reach a 6 plus, so that means each is 3 plus. Therefore, we call it iron 3 oxide. Now let's try a few. This one, simple. Right? Potassium's all the way in group 1. Chloride, of course, is chloride. Potassium chloride. Notice there's no Roman numeral. Be careful and look, when you're looking for your elements to name them off the periodic table, make sure you look at the column that they're in. Unless they're in where the transitionals are, you're not going to use a Roman numeral. Please keep that in mind. This one, again, simple. Sodium nitride. Again, notice there's no Roman numeral. Okay, now try this one. All right, look at where Cr is in your periodic table. It's a transitional element, so we call it chromium 3 nitride. All right, location in the periodic table will help you determine whether you need to use these Roman numerals or not. Okay, let's try this one. Scandium 2 phosphide. Okay, scandium is in the transitional metals. All right, lead. Now, lead is outside the usual transition, but if you look at where it is, it's really under the group 4, where the copper and nitrogen groups are. Therefore, it is a special transitional metal, even though it's not the usual transitional metal group. So we call it lead 2 oxide. Because, in this case, you get lead 4 oxide. Lead can have a +2 or a +4 charge. And this, of course, is hydrogen selenide. In the area of ternary compounds, ternary ionic compounds mean more than one, and they usually use the polyatomic ions, of course. There are at least 3 elements. Again, in ionic compounds, you just need to name the ions. So we'll try this one. Sodium nitrate. This, calcium and sulfate, calcium sulfate. All right, notice this copper, there's only one copper. This is sulfite. Sulfite's -2. Therefore, we call this copper 2 sulfite. And with the ammonium, it's ammonium oxide. Right? In this case, we're in a group 1 metal, so we call it lithium cyanide. Again, notice no need for Roman numerals. All right, be careful, back to transitional. This is iron 3 oxide, or hydroxide, excuse me, it's hydroxide. Nickel, also transitional, nickel 3 phosphate. And you can have an ionic compound with nothing but polyatomic ions, and this is, of course, ammonium carbonate. Writing formulas. When you're writing formulas, the key to remember is that the subscripts you're going to use will get you to the point where the charges will add up to 0. Okay, so you get the charges on the pieces or on the ions of the elements. Cations come from the name on the table. Anions come from the table, or the polyatomic ions, which of course we've all memorized. Balance the charges by using subscripts to include additional atoms or additional elements as you need them. Put polyatomics in parentheses if you need more than one. You'll see how this works in a little bit. So let's try calcium chloride. Calcium is a 2+, it's in group 2. Chloride is, of course, a 1-. If I just use one of each, I would end up with a 1+ charge, and that's not a formula. It's not a properly written formula. So to write it properly, I need 2 chlorides. Therefore, I write it as CaCl2. Now notice, I can also use a method called the crisscross method, where since calcium, where I take the charge of the cation and put it as the subscript for the anion. And you can practice a few of those. And I actually have a worksheet that you'll find on my Edmodo or on my eBoard site that will help you understand and utilize crisscross if you want to try that. Okay, let's try lithium sulfide. Sulfide, of course, being S, -2, it sits under oxygen, therefore you will write Li2S. Tin 2 oxide, simply SNO. Tin 4 oxide, of course, is SNO2. And magnesium fluoride is MgF2. Okay, as you can see, we have these others. Copper 2 sulfate being CuSO4, iron 3 phosphide being FeP, gallium nitrate being GaNO3, and iron 3 sulfide being Fe2S3. Okay, let's try a formula for ammonium chloride. Simple, NH4Cl. How about ammonium sulfide? Well, you put that in parentheses, NH4, 2 in parentheses, S. Okay, notice this is where the parentheses come in with polyatomics. Barium nitrate, also having to use parentheses. Remember the things to look for when writing formulas or naming compounds. If the cations have parentheses, the number in parentheses tells you their charge. So if you need to write a formula and you see that number in parentheses for the cation, remember that's the cation's charge. Anions end in IDE, and if that's the case, they're going to be probably monatomic and you can get them off the periodic table. If it ends in ATE or ITE, then that should trigger a polyatomic name for you. Sulfite, sulfate, phosphite, nitrate, etc.